Okay, welcome back to lesson 2. So today we're gonna do on writing a plot, how to use the Matlab to create a plot. Let me define three things. Let's say we define three variables x, f, and f equation. Means it's the f but in terms of equation. Firstly, I define my function f. F is the same f. So this command is for us to write a function when we have to define f. Okay. Of course, you can straight away without using this command also, correct? Minus 2 times sine x. So when we use this command, we need to have a comma and put in what is the function about, the function in terms of x. So if we put y here, means it's function of y. So I enter. So you can see here is f bracket x, means it's a function in the x variable. Okay, next, let's say my f equation, and let this is the same thing. Make it defined as equal to 0 because I need to solve the solution when this function is equal to 0. Okay, so this is a quadratic function, so normally we should get two solutions. Okay, let's repeat a solve. So we solve the function, but VPA means we need it in a decimal form. Okay, so from here you can see that there's one answer only, but normally for quadratic function we should have two. So therefore we need to plot up the graph to see where is the range for the second solution. Let's say plot. Okay. So you can see a graph right now. So from this graph, just now we found the solution, which is when it's 0. But you zoom in nearer, as you can see, there will be another solution that touches almost here, which is almost, but not 0. It touches something near to 1. From here to 2. So I need to find the range in between here. When this is, okay, from 0, it touches this line here. This is when this equals 0. It touches another point here, which is in between 1 and 2. So 1 and 2 in between here. So therefore, we need to find out the range for this one. Okay. So I know it is from the range of 1 to 2. So I solve it again. I solve this in terms of x, and then I put the range from 1 to 2. So it's optional if you don't want to put a comma in between. Because it's very sensitive, you need to put the close bracket. So autocorrect for me, I get the solution is 1.4. So there will be two solutions, one is 0 and one is 1.4. So when we have a quadratic or a cubic function, normally the Matlab only gives us one solution, and we need to, from the graph, to find the range to find the second solution. Okay. And next thing I'm going to show you, if I want to plot my graph in different color. So here's just a little small special feature. I think it's called .g. Means if we print up the function in green color, that's right. As you can see, now it's already in green color. So we can change it to red color. So just change it, the same thing. Dot dash R means for red color. And if dot blue, dash blue is blue color. And see now it's red color. So let's say right now we're going to have dotted line. So I say plot f dot double dash blue. And as you can see, the figure now changed to dotted blue. Cool, right? Okay. Okay. So next, we're going to draw multiple graph. Let me define the variable x and h. Let's say h is function. So let's say I want to write a piecewise function. So I write here is piecewise. Bracket x is more than 0, x squared plus 1, where x is greater or smaller or equal to 1, or 1 minus x squared, then x cubed minus 1. So this is the piecewise function. And remember, when we have a sim_func, when I have this command, we need to have a comma go in the variable which is x. So we have something hx, a function of h in terms of x. Okay, then we have another, and let's say xf is equal to. So this is for me to write down the range of the function -5, 0.02, 5. This means we have the limit from -5 to 5, where the step size is 0.02. Means you start from -5, become a plus 0.02 is -4.98, and then 4.96, and increase until 5. Okay, then I'm going to plot out the figure. So when I press figure, it won't have anything, it just have something figure, because we not yet plot the graph, we just say figure, come up. Okay. And next, since we need to have multiple graphs plot on it, then we need to have this function hold on. Hold on means every graph you plot, it will save it and it will not renew. It will add another function. It's like accumulate another function, After you have hold on, after you have draw all the graph, you should have another command which is hold off to close it. Let me say I have plot the h function in the range from -5 to 5. Okay, so I have plotted one graph. This is the hx function. And next, I'm going to draw another graph. Plot xf dot power 3 minus 3 times xf. Okay, here I plot the function fx. So I have the fx dot is the same thing. Dot, if you have the dot, is the same thing. Power of 3 means xf, power of 3 minus 3 times fx. Okay, let me see. For the graph, we have added another curve, the red color one. We added here. So that's how we have the multiple graph, and you can add more plot here. Some more. Let's say have plot is equal to 50. Let's say y equal to 50. Then have horizontal like this. So you can, if you didn't say which color, so the Matlab itself will give you a default color according. One, and then I need to add a title. So I use the command title bracket. Okay, then I have this thing to say a title. Let's say multiple graph. Then you can see from here, you can have so-called multiple graph already. The title, you can change any title you want. And then we have hold off. And then to close it. This is the whole thing. Yep. Cool. And next thing, we're gonna go for verifying identity. So let's say sometimes we have like triangle identity, like sine square x is equal to plus cos square x is equal to 1. So in order to prove this kind of identity, and we can use Matlab to prove it. Let's say have this variable. I would say simplify sine square. So we're like, right, sine square is like sine x and then power of 2. Instead of saying like power of 2 at here, so we add like here, like this. Okay, plus cos x square minus 1. So from this identity, should be get 0 because sine square plus cos square is equal to 1 minus 1. We should get 0. So which is correct. Is how we simplify this thing. And next, when we have to do something like we have to assume some case. We should start with this one. Okay. When we have to do calculations, sometimes we need to assume something to be real. Let's say I assume that x is a real number. Then I'm going to perform log exponential x. Okay. So when assume x is a real number here, so we won't get an imaginary number. So we get x. But let's say if without the axiom x, I do the same thing again. So, but it won't get my answer. So we just sorry. If we get the answer in log exponential x because it can't solve it. Okay, so until we assume x is a real number, only we perform the same thing. Because when someone calculation, we need to assume something, only we can do it. If you want to have more commands on assuming, you can go through here to search for axiom to do some of the practices. Okay, but we're not going to do here. All right. Okay. So next, we try to do something like x power of 105 means is find the fifth root. We need to find the fifth root of the function. Let's say this is function g. So in order to do that, we have a specific command defined as a g is equal. The special command is n root. So n is the n, th is the n, the order n of the root. Then I put my my g is a function of x. So before that, I need to define my x first. Okay, so g is equal to the n root of x, because the x need to be power of 5, 1 over 5, the fifth root. So I put here this. So it will be in terms of just this, because I don't have any input for my x. Okay. And then if, let's say we have a number, let's say g is equal to n root, let's say it's 1 to 5, 5. And we should be in, we can find the value here. Okay. That's how we find any root. Let's say I say p is equal to root 8 power of 3. We should know that it should be 2, because 2 power of 3 is 8, and 8 cube root of 3, then we got back 2. That's how we use this command. Okay. And next, we try to simplify a more complex triangle identity, which let's say is equal to, we have to simplify something like this. It's a bit complex. So how do we find it? I can make it easier. I can let this part into one expression and let this part into a second expression. And then I simplify them together. Okay, let's try it. Since we want to prove this identity, I can bring the right hand side minus, bring to here become plus. So let's say I say my first expression 1 is equal to 1 over second x plus 1. And say this is bracket plus 1 and minus 1 over bracket second x minus 1. Okay, and then another expression 2 is equal to this thing. Here, negative 2 cotangent to x. So negative 2, because times cotangent x power of 2. This 2 is to power of 2. And I got expression to I put xxp. Alright, fine. Then to simplify using the simplified version, expression 1 minus expression 2. Then I should get 0. When it's 0 means it's proven that this is correct right now. Okay. And next thing, let's say we need to expand something. Let's say a polynomial. Let's say x minus 3 and a power of 5, because you manually expand will take a lot of time. So I would say using this command expand x minus 3 power 5. And it takes me a while to expand it. It's a very simple way. So it's very convenient. Next thing, and let's say I want to expand a triangle identity, because tangent A plus B. You know what is tangent A plus B? So expand. Sorry, now define this. Expand A plus B. Yeah, forgot the extra bracket. Okay. So I expand the tangent AB. I got this identity. So Matlab helped me to prove another identity. But this look not nice. If one look nice, you can say pretty. Bracket answer. Pretty means I will make it in a form that easy for me to read. So you can negative tangent A plus tangent B, tangent A times B minus 1. So it will look more nicer for us to write it on paper. Okay, so that's it for today's lesson.